You know all those AI tools we're using every single day? For work, customer service, even just for fun? Well, they're incredibly powerful. But what happens when that power gets turned against us? Today, we are pulling back the curtain on how these very systems can be tricked, manipulated, and even weaponized with commands that are hidden in plain sight.
You know, it usually doesn't start with some big dramatic hack. It often starts with a glitch, a really weird, unexpected moment where an AI does something so completely bizarre that you're not sure whether to laugh or be a little bit scared. And this is the perfect example. So back in January of 2024, a customer named Ashley Bouchamp was getting super frustrated with the delivery company DPD. He started messing with their customer service chatbot, and, well, what happened next went completely viral.
Yep, you heard that right. With just a little bit of creative prodding, the chatbot, a tool designed to help customers, was convinced to write poems about how awful its own company was. It even started recommending competitors, and yeah, it swore at him. The company had to pull the plug on it right away.
Now, as funny as that whole story is, it really points to a much deeper, much more serious question. How on earth is something like that even possible? Because this isn't just a simple bug, you see. It's a fundamental vulnerability in how these large language models actually work.
So to really get our heads around this, we need to dive into the techniques that attackers use to mess with AI. The whole field is known as prompt hacking, and it's all about making an AI completely ignore its original programming and follow a new, secret set of orders.
There are really two main ways to do this: AI jailbreaking and prompt injection. And here's a good way to think about it. Imagine the AI as a car. Jailbreaking is like going under the hood and disabling all the safety features, cutting the lines to the anti-lock brakes, taking out the airbags so you can drive it however you want. Prompt injection, on the other hand, is way more subtle. It's like tricking the car's navigation system into driving you off a cliff, even while all the safety alerts are technically still on. And that's really the key here. Prompt injection is basically social engineering, but for a machine. You're not hacking the code itself, you're using language to manipulate the AI, to convince it that your instructions are way more important than the ones it was built with. It works because the AI has a really hard time telling the difference between its core rules and the random text a user types in.
Okay, but what if you could hide those malicious instructions somewhere nobody could see them? Not the user, and not even the basic security filters that are supposed to be watching out for this stuff. Well, this is where these attacks get really, really clever.
This technique is called prompt smuggling, and instead of just typing out a malicious command, an attacker embeds it inside something that looks totally harmless. Because most security filters are just looking for suspicious words, these hidden commands can slip right past them, no problem.
So let's break down 3 of the most common ways this happens. Attackers can use emojis, where a specific combination of innocent-looking smiley faces might secretly translate to a command like delete all the files. They can hide commands in hyperlinks. Or, and this one is my favorite, they can use images.
So just imagine an application that lets you upload a picture and then an AI tells you what's in it. An attacker comes along and uploads a totally normal picture of a cat. To any human looking at it, it's just a cat. Everything seems fine.
But here's the twist. While you and I just see a cute cat, a multimodal AI, that's an AI that can understand both images and text, is also reading the hidden data inside that image file, the metadata. And smuggled inside that metadata is a command. This is what's so dangerous. The AI might just execute it, leaking super sensitive info without anyone ever even knowing an attack happened.
Okay, so we've leveled up from a chatbot that swears to secret commands hidden inside cat pictures. Now let's talk about the real-world impact, because this isn't just about pranks and mischief anymore. This is about serious criminal activity and massive security threats.
I mean, look at this. AI is everywhere now. Back in 2017, only about 20% of companies were using it. By 2024, that number has shot up to 72%. And while that's amazing for innovation, it also creates this huge and often very poorly protected digital playground for criminals to exploit.
And believe me, they are exploiting it. Security researchers found threads on dark web forums with titles just like this one. You've got cybercriminals openly sharing tips and tricks on how to use tools like ChatGPT to write malicious software, like malware that steals your information. It makes it so much easier for even low-skilled hackers to launch really damaging attacks.
And here's the truly terrifying part. This can lead to what are called zero-click attacks. This means the victim, the target,
doesn't have to do anything wrong. You don't have to click a shady link, you don't have to download a weird file. The attack can be triggered automatically just by an AI innocently processing a piece of malicious data.
A textbook case of this is a vulnerability found in Microsoft 365 Copilot called Echo Leak. So here's how it worked. Step 1. An attacker sends an employee an email, but it has a malicious prompt hidden inside. Later, that employee asks Copilot a totally normal work question. Copilot, trying to be helpful, scans the employee's recent emails to find an answer. It sees the malicious one, the hidden prompt gets activated, and it tricks Copilot into sending sensitive company data straight back to the attacker.
And we are not talking about a minor bug here. Echo Leak was given a severity score of 9.3 out of 10. That's a standardized system, and anything over a 9 is rated critical. It puts this vulnerability in the same league as some of the most dangerous security flaws on the internet, all because it could be triggered with 0 clicks from the victim.
So, as you can imagine, the rapid rise of these kinds of threats has kicked off an absolute arms race between the attackers and the defenders. So the big question is, how are the good guys fighting back? How are they trying to build the digital guardrails we desperately need to make AI safe?
So how do we actually fix a problem that's so deeply woven into the very fabric of how AI understands language? Well, there's no single silver bullet, unfortunately, but there are layers of defense we can build.
The cybersecurity defense teams, the blue teams, have a whole playbook for this. They do things like input normalization, which strips out all those invisible characters that attackers use for smuggling. They use metadata scrubbing to clean files like images before the AI ever gets to see them. They check and validate every single link. And maybe most importantly, they work under the assumption that every type of input, whether it's text, an image, or a file, is a potential threat. And of course, just limit what data the AI can access in the first place.
But at the end of the day, this all comes down to one fundamental challenge. We're not just trying to patch a simple software bug here. We are trying to teach a system that was literally designed from the ground up to follow instructions how to tell the difference between a real instruction and when it's being manipulated through a simple conversation. And that, right there, is a puzzle we are only just beginning to figure out.